We'll talk about a few properties that logarithms possess today. We'll start with a pretty foundational property, the relationship between logarithms and exponential functions. So, logarithms were defined in terms of exponential functions as literally just being another way to write exponential statements. So the statement that the logarithm base a of b equals c, and the statement that a to the power of c equals b, these are the same statement, just written in different ways. So presumably, if you look at the function f of x equals a of x, and the function g of x equals the logarithm base a of x, these functions are related to one another in as much as these statements are related to one another. And the relationship that we see here is that these functions are inverses. So f of g of x equals x, and g of f of x equals x. And let's take these statements and let's rewrite them. Let's actually do this composition. F of g of x, well, we go to f, and we see the input on the left, and the same input on the right. So if we're replacing the input on the left with g of x, we need to replace the input on the right with g of x. And this statement that f of g of x equals x becomes the following, that a to the logarithm base a of x equals x. This statement, if you do the composition, becomes the statement that the logarithm base a of a to the power of x is x. So logarithms and exponentials undo one another. They are inverses of one another. And that's going to give us a way to deal with exponential equations. Before I get to that, though, let's just make a few remarks about this fact. We have stated that the range of a function is the domain of the function's inverse. And we have stated that the domain of f of x, a function, is the range of its inverse. And that has been true for exponentials and logarithms. So if we look at, say, the common logarithm and 10 to the power of x, and we look at their domains, and we look at their ranges. 10 to the power of x has a domain of all real numbers, which we said yesterday is the range of the logarithms. The logarithms, we said yesterday, have domains of the strictly positive numbers, and that is the range of exponential functions. Furthermore, we have said that if we look at the graphs of logarithm, we have said that if we look at the graph of a function and its inverse, the graphs are mirror images of each other over the line y equals x. And that is precisely what we see here. So for example, this point at 0, 1 is reflected over here to this point at 1, 0. This point at 1, 10 is reflected over here to 10, 1, and so on. So exponentials and logarithms are closely related to each other, as one would expect from the definition of a logarithm. They are inverses of each other. Let's see. Hello, everyone who's come in. You didn't really miss a whole lot. I will always start at 1, even if there's no one there. That's because remember that I post recordings to Sakai. But all you really missed, I mean, we just talked about what's on this paper. I made the observation that logarithms and exponential functions must or look like they are closely related to each other. And then I said that in particular, they're inverses of each other. And you came in just while we were talking about that. Let me now talk about using this property to solve exponential equations. Just give me half a minute while I get our emulator up. See, I know you can't see it. I haven't shared the screen yet. We will need it.